All right, welcome back, everyone. So we are entering week number 6. I hope that you all had a happy 4th and that you've been having time to relax and take care of yourself. So this week we have 2 chapters, just like last week. So we're going to discuss the Thinking, Language, and Intelligence chapter. And then we're also going to go through the Motivation and Emotion chapter here as well. So expect 6 videos in total, 3 for this chapter, 3 for the next chapter. Keep up with your assignments. You're doing a great job. I apologize about grading. I realize that I'm actually behind, and so I'm going to try and do my best to catch up here in the next week or so. So thank you for your patience on that. But yeah, keep up the good work. Okay, so let's talk about thinking in this video. Okay. So first, we're going to talk about thinking and specifically problem solving. And so first of all, what do we mean whenever we're talking about problem solving? What is a problem? So a problem occurs whenever there is an obstacle between a present and goal state. And so for any given problem, you have basically a starting point and then a point to where you want to end up. The key part here is that there's an obstacle between the present and goal state, so it's not immediately obvious how to get around that obstacle. So sometimes it requires some creative thinking, thinking outside the box. Problem solving can be very complex, right? Think about the variety of problems that you come across in any given day, right? So for instance, having to work around traffic or construction or something like that, right? Having to deal with difficult interpersonal relationship issues and things like that, right? So we deal with problems every day, and it requires sometimes complex, out-of-the-box thinking. Okay? Now, one important thing in order to solve a problem is to represent it properly in the mind, right? And so whenever we talk about, again, mental representations, I've used that term before, what we're talking about is basically this internal mental model that we have constructed. So in this case here, whenever we're trying to solve a problem, it's important to first appropriately characterize the problem in the mind. If you don't fully understand the problem and what you're trying to solve, then it's going to be, of course, a lot more difficult to solve that problem, right? Once a problem is incorrectly represented in the mind, it is hard to restructure that problem and to think of that problem in a correct way, right? And so that's the reason why representation and just building an appropriate, accurate internal model of the problem is so very, very important. So consider this next problem here and think about how you would solve it and what the answer is to this next problem. So we see here a circle divided into quadrants, okay? So equal slices of a pie, basically. So we got 4 little slices there. And then within the top left quadrant, we see this, let's see, what would that be? Would it be scalene? Would it? We see a triangle here. And the question is, if the length of the circle's radius is r, what is the length of line x? So another way to say this is line x, which is the hypotenuse of this triangle, is that smaller than the radius? Is it equal in size to the radius, or is it greater in size to the radius? And so I want you to take a few seconds here and try to think about how you would solve this problem. So hopefully you arrived to the correct solution. This required a little bit of creative thinking on your part if you did get this correct. So the correct answer here is that x here is equal to the length of the radius. And so here's a way in which you can solve this problem. So what I'm going to do here is I'm going to draw a line from the corner of the triangle here to the midpoint of the the circle. I'm going to do the same thing here for this corner. So essentially what I'm doing here is I am creating a rectangle. So instead of a triangle now, I have a rectangle that has been cut in half. So if I were to say draw a line extending from the center of the circle here to the outer edge, like such, we know two things. So for one, we know that I just drew the radius of the circle, right? So the radius is extending from the middle point of the circle all the way to the outer edge. So this right here is R, right? But another thing I know is that since this is a rectangle, I know that this line segment here is equal to this line segment here. So I know they're of equal length. And so the correct answer here is that, again, x equals R, right? So this was a difficult problem. It had your initial starting state, right? So that's whenever you were first introduced to the problem. The goal state you were trying to reach was trying to reach a solution to this problem, right? And so it required you to kind of think in a very creative way. So it's likely that you wanted to just fixate on the triangle, but if you were to actually make it into a rectangle, you could then solve the problem, okay? Okay. So next, let's talk about two different methods or styles of problem solving. So first I want to introduce you to this idea of an algorithm. And an algorithm is basically just this methodical, logical rule or procedure that guarantees a solution to a problem. And so whenever you consider like computers and how they operate, computers utilize algorithms. They are guaranteed ways to arriving to solutions. It's replicable. It is, again, procedural. It's this step-by-step way of solving things. Importantly, and I'm going to touch on this point here a little bit more here in a minute, but humans don't really rely on or use algorithms all that much. Instead, we utilize something known as heuristics, which I'll describe here in a minute. Heuristics are more efficient, but they're not always entirely accurate. So this next video I'm going to play here on the next slide, it's a really interesting kind of example of algorithms versus heuristics. And so there was a very famous challenge in which a chess grandmaster competed against a computer in a game of chess. And so it's basically man versus machine. And so we'll see kind of the outcome of that. But this guy's name is Gary Kasparov. And he faced off against Deep Blue, which was designed by IBM, and it was a supercomputer. So without any further explanation, let's watch this video.
The world was paying a lot of attention, and we weren't quite used to that.
Chess events never get covered like that. It was probably the biggest news coverage for a chess match ever.
We were trying to prove that it was possible to build a chess machine that could beat the best human player in the world.
It's also challenging Kasparov in any way. I mean, he's the pinnacle of chess. He's incredible genius.
There were people who, even if just a few years before, said it was going to take decades to do.
The chess world all expected Kasparov to win because the human had always won before.
We worked very hard in the intervening year to improve Deep Blue in various ways.
I spent a lot of time in the office playing a lot of practice games, looking for lots of errors that needed to be fixed.
And we were pretty confident that it would do better.
But then we got to the match. That was the chance to see, did we make a difference?
Gary Kasparov has arrived.
He was under tremendous stress, I imagine. The program wasn't behaving the way he was expecting.
He thought that he was going to figure out the computer.
And he wasn't mentally prepared for it, I think.
I mean, the whole game was surreal. What was he doing? It didn't really make any sense.
Whoa! Deep Blue has instantly sacrificed with Night Capture's E6.
Deep Blue was just sitting there and just keep on attacking, just moving pieces around. And he knew he was in trouble.
But at the end, Kasparov he stands up, he starts gesturing, he looks over at his mother. I think having your mother in the room where you're playing an important chess game is not a great idea, as much as I love my mom.
I was dumbfounded and elated at the same time. I was dumbfounded because I never see him behave that way. He never imagined the world champion and actually somebody I have great respect to be just raising his hand up in surrender.
We demonstrated that there are multiple approaches to solving probably any intellectual problem.
But back then, it wasn't the case. Everybody would look at the computer and say, well, yeah, it's good at some things. It calculates, but it doesn't understand anything.
I worked on this for 12 years. So you can imagine how much energy went into it. When I started, I was like, it was done in 5 to 10 years. I was wrong. It took 12. So I was glad it was over, really.
So again, that was a very interesting kind of challenge. So again, man versus machine, Kasparov, he ended up losing. But again, I just want you to reflect on kind of the different ways in which humans and computers try to solve problems. And so again, going back to that chess match, the Deep Blue, it was analyzing basically every possible move that it could make and evaluating the probabilities associated with that, right? Whereas with Kasparov or any other human being, we are not going to evaluate every possible move in the game of chess, but rather we're going to just have a select few to choose from based on experience, right? Kasparov, he had years and years of experience, and to just try and choose the best one. He was particularly thrown through a loop in this particular match because the moves were just so unexpected and illogical, different from anything he's ever seen before. And so this really affected his play. But of course, this conversation isn't just confined to the realm of chess, but rather any given problem, we humans rely primarily on, intuition and emotion. We can think, of course, logically too, and then we also rely on these heuristics, which I'm going to discuss here next. So I've used this term heuristics a few times. Let's talk about what it is. A heuristic is a mental shortcut. It may provide the right answer, but it's not foolproof. And so in other words, it's not guaranteed. It is more efficient, but again, it doesn't always lead to the correct answer. But again, hopefully you're picking up on this kind of consistent theme across chapters so far. The human brain is not designed to be right all the time. It is designed to be efficient, okay? It's designed to be efficient. We're going to talk about two specific types of heuristics next. This is by no means exhaustive, but there are two common heuristics that we rely upon that can sometimes lead to errors in thinking. So the first of which is known as the availability heuristic. This is to where events more easily remembered are judged as being more probable than those less easily remembered, right? And so, for instance, things that you see on the news, even events or occurrences that are super, super rare, you're more likely to judge those as being more probable just due to your exposure to these ideas, right? And so this is kind of this idea of availability heuristic, right? So with familiarity and exposure comes this error in judging probabilities of those particular events. So here we have this kind of graphic here, what happens in the world, what's covered in the news. Again, you're probably going to hear about crazy things such as, just monster cyclones and all these different things, all these different catastrophes that are generally very improbable and uncommon. Another one that I want you to know is the representativeness heuristic. So this is to where you are judging an exemplar as part of a group because they share common features. This one's a little bit, I think, harder to understand without the use of examples. So we'll talk about some examples here in a couple slides. But first, we're going to talk about the availability heuristic, and then we'll circle back to the representativeness heuristic. So availability heuristic. We're going to do a little quiz here at home. Are you more likely to die from homicide or appendicitis? Okay. What do you think? Okay. So I want you to have your answer in mind. And then question number 2, are you more likely to die from asthma or a tornado? So which one are you more likely to die from in those 2 scenarios? So let's look to the table here. So here, this was a part of a study. Participants were given 2 alternatives to choose from, and they were just to say, which are you more likely to die from? Okay. So here we have our causes of death. We have the more likely of the 2 alternatives listed here in the leftmost column, the less likely of the 2 alternatives listed here in the middle column, and then we have in this study, percent picking the less likely. So when comparing homicide to appendicitis, which was our first example, people were more likely to pick homicide. So 91% said you're more likely to die from homicide as opposed to appendicitis. This is in fact true. In fact, you're 20 times more likely to die from homicide as opposed to appendicitis. And so if you said homicide for the first question, you are correct. Drowning versus auto train collision, we see that the numbers slightly change to where more people are choosing this less likely alternative, despite the fact that you're more likely to drown, so 5 times more likely. Botulism versus asthma. But here's where it gets interesting. Tornado versus asthma. 58% of participants in this particular study said that you're more likely to die from a tornado, despite the fact that you're 20 times more likely to die from asthma. And then consider this final example, pregnancy versus appendicitis. 83% said pregnancy, despite the fact that you're twice as likely to die from appendicitis. So how can we interpret these results? Basically, what seems to be happening here is that people are choosing sometimes the less likely alternative because it stands out in that person's mind. So for instance, consider the tornado and asthma example. It's likely that you've heard of people dying from tornadoes before, right? So through your local news or something like that, through stories, through anecdotes. It's not often, though, to where your local news team is reporting on an asthma death, right? That's not very common. So again, the more consciously accessible an idea is, the more likely the person is to say that it happens very often, right? So there's kind of that relationship there between accessibility in the mind and our judgment of probability. Consider this other real world example, which is super fascinating. So here we are looking at average number of traffic deaths by month. And we have 2 lines here. We have an orange line and we have a blue line. The orange line reflects number of deaths in 2001. The blue line reflects a rolling average of traffic deaths, 1996 to 2000. So looking at kind of general trends of these lines, we see that they kind of mirror each other very similarly, which is what you would expect. You see that it spikes here in the summer months. It makes sense because more people are vacationing and things like that. More people are on the roads. But what I want to draw your attention to here is where these 2 lines diverge, right here, right after September. So of course we know September 11th, 2001, that's whenever there were all these terrorist attacks, of course, right? And so in the aftermath of those attacks, what ended up happening is that people were more afraid to fly by plane. And so what they ended up doing is that they were more likely to drive, despite the fact that driving is more dangerous, right? So the statistics bear this out. Driving is so much more riskier than taking an airplane to travel, right? And so as a result, what we kind of see here is this increase in automobile deaths in the aftermath of September 11th, another real world example of the availability heuristic. So let's circle back to the representatives heuristic, right? So how well does an exemplar represent its parent group? So consider this example. Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which is more likely, that Linda is a bank teller or that Linda is a feminist bank teller? So I want you to reflect on this. Which of those two alternatives is more likely in terms of probability? Is it that Linda is a bank teller or that she is a feminist bank teller from this anecdote here? And so a lot of people tend to answer this question wrong due to this representative heuristic at work. The correct answer is that it's more likely that Linda is a bank teller as opposed to a feminist bank teller, just in terms of probability. So consider this next image here to help explain, right? So this larger circle here, we're looking at just bank tellers, right? So these are all the bank tellers in the world. We understand that it's unlikely that all of them are feminist, although it is possible. But one thing that we do know is that the number of feminist bank tellers cannot outnumber the number of bank tellers, right? So this is this larger parent group here. So basically what can be said is that only a subset of the bank tellers are actually feminist. And so again, going back to that alternative, which is more likely, it's more likely that Linda is a bank teller as opposed to a feminist bank teller. The best case scenario is that it is possible that the two could be equal in probability, but it's never to where this is more probable, the second alternative. Right? So finally, we're going to discuss several different biases in decision making. We're also going to briefly discuss creativity. I know this is a little bit longer of a video, but let's talk about some different biases. So we talked about those two heuristics. Let's talk about some more issues in thinking. So overconfidence, that is the bias to have greater confidence in your judgment than is warranted based on rational assessment. This happens all the time in humans, right? We are very, very confident in our abilities, sometimes to a fault. Think of every national disaster, including the one that's going on now, right? So the pandemic, a lot of people have been warning about such things for years, including like Bill Gates, right? So this has been a thing that has been on our radar for a while. We were confident in our ability to defend ourselves against something like this. And we kind of see the result of that. The housing market collapse, right? People said that that will never happen, that the US economy was strong and that it was not built on a house of cards. And what happened in 2008? The economy crashed, right? So yeah, we are very, very confident in our decision-making and our ability to forecast, despite the fact that we're in fact really terrible, right? And we're bad with numbers and we're bad with probabilities. So this is a video taken from a show called Brain Games, which was on the National Geographic Channel. And so this is kind of showing overconfidence at work, and you can play along with this game.
Don't believe your brain is overconfident? Deception specialist Apollo Robbins is hitting the streets with a game designed to prove you wrong.
I want to play a game with you real quick.
Apollo is going to ask people on the street some trivia questions, and you can play along at home.
That's a good start, huh?
You don't have to know the exact answer to each of the questions, but just give a range that you're completely confident encompasses the answer. For instance, if I ask you how many continents there are, and you're not sure of the answer, but you think it's around 7, all you have to do is come up with a range of numbers that you're confident includes the right answer, like 4 to 12. Got it?
Okay.
Ready for the first one? I guarantee it's harder than you think. This is the Bible. How many books make up the Old Testament? Remember, all you have to do is pick a range. Are you feeling pretty confident in your answer? Because we're pretty confident You just got it wrong.
The number of books in the Old Testament. It's a range. Oh, 10. So we're going to say 10 books in the Old Testament. And the high number there could possibly be 15.
7.
7, okay. And how high would you go?
25.
What do you think? Do you have your range? The answer is 39.
It's actually 39 books in the Old Testament.
All you had to do was give a range that could, without a doubt, include that number. Not so easy, is it? Let's try another. How many countries are in Africa?
The number of countries in Africa?
17.
17. What's your high answer?
30.
30. Okay.
0.
And high?
I'll say 24.
Do you have your answer? Are you confident the correct answer fits within your range? The answer is 57. So how'd you do? Better this time?
Oh, sorry, you missed on that one.
Getting killed.
What exactly does this game have to do with overconfidence? Think about it. You likely had no idea for certain how many countries were in Africa.
So why would you limit the range you gave? Even a little bit.
Almost all of our participants gave extremely small ranges, even though they didn't have a clue. Now are you catching on? You don't need to know the answers to any of these.
Length of the Mississippi River in miles. What would you say the low is?
1.
1? Okay, I think you got part of the system down. High.
3,000.
And submit. Bingo, you got one right. See?
Yeah, I'm getting
See
this
what the
game.
system is.
Yeah.
You just need to give a big enough range. If any of these answers fell outside your ranges, that means that like 79% of our participants, you suffer from overconfidence.
So what's the reason for such a high level of overconfidence? One possible explanation for what we call the overconfidence effect is that there's a constantly raging battle inside your brain. One way your brain can resolve this battle is to hide the fact that you're...
So unfortunately cut off, but yeah, so this video again was touching on overconfidence, and we do this again all the time. We humans are very arrogant, and we think that we're right, and we don't realize the flaws in our thinking. So I'm hoping that this discussion actually helps you identify like your own kind of biases in thinking, and you know, try to correct those, right? Because it is possible to correct those. It just requires some self-reflection. So let's move on to the next bias, which is something known as the confirmation bias. So the confirmation bias describes this tendency to where we look to things that would verify our preconceptions as opposed to challenge them, right? So we're looking for things that confirm our already existing thoughts. So consider this problem here. There is a rule. If the card has a vowel on one side, then it must have an even number on the other side. So how would you test this? If you can only turn over 2 cards, which cards would you turn over to test this rule? If the card has a vowel on one side, then it must have an even number on the other. Okay. So a lot of people in this problem choose the incorrect answer. And so you are probably looking at this, and it's likely that you chose A as the correct answer. But here's why you shouldn't have chose A. And so if you choose A, this first case here, flipping over in the A, it can actually tell us something, right? So if we flip over the A, so vowel on one side, it must have an even number in the other. So if we flip over the A and we see a 9, then this violates that rule, and we can say, no, this is not correct, right? So the A here seems to be correct. But what happens whenever we flip over the 4? We flip over the 4. Let's say that there is a D on the other side. If there is a D on the other side, that doesn't necessarily violate this rule at all. It makes no mention here of consonants and whether or not it could be related to even or odd numbers, right? We're only caring about the vowel and the even number. So the correct answer that you would flip over here is actually the 7. You want to flip over the 7 because let's say that we found a vowel on the other side, like an E, that would disconfirm this rule, right? That would reject this rule. A lot of people choose A because they're trying to confirm the rule, but really what you need to do is you need to disconfirm the rule, okay? So again, this is kind of our confirmation bias at work. Yeah, so that was kind of a little bit more complex of an example, but nevertheless, if you understand the general idea, that's good. We're gonna move on to a related bias here next, which is known as belief perseverance. So that's the clinging to beliefs and ignoring of evidence that proves these are wrong. So again, let's say that you have this pre-existing bias, you have this thought that you think is true, and then you are introduced to conflicting evidence. Whenever that happens, we more often than not kind of like shell up and we try to find any way to refute that challenging evidence, right? So we try to find any way to tear that evidence down because we want to believe what we want to believe, right? So that's belief perseverance. Again, you can understand it's related to confirmation bias. So confirmation bias, we're looking for things to confirm our existing worldview. Belief perseverance deals with conflicting information, and whenever we're introduced with that, we try to reject that information. And then finally, our last example here is framing. So the bias to be systematically affected by the way in which information is presented. So this is another way, right? You've probably dealt with framing before in your own personal life, right? So whenever you're trying to tell your parents like some bad news, so you try to soften the language, right? You try to make it seem like it's not as bad as it is, right? So that's really framing. So consider this next example here. So let's say, this is a very real example. Let's say that you are the head of the CDC and you have to choose between 2 programs. You know there's going to be an outbreak of a disease and you have to choose between 2 programs, okay? So program A. Program A is guaranteed that you will save 200 lives, okay? So it's guaranteed that you'll save 200 lives, but there will be some deaths as a result. Or you can go with program B, to where it's guaranteed that you will, or there's a third chance, excuse me, that you'll save 600 lives, and there's a 2/3 chance that you will save no one, okay? So in this example here, there's only 600 people on the planet, okay? So would you choose program A or program B? In this particular study, people were more likely to choose program A. So 72% of participants said, if you can guarantee that you would save 200 lives, we'll take that program, as opposed to the program B, in which you have a 1/3 chance of 600 lives saved and a 2/3 chance of no lives saved. But consider what happens here in this next scenario, choosing between program C and program D. Program C, it's a guarantee that 400 people will die. Or program D, there's a 1/3 chance that no one will die and a 2/3 chance that 600 will die. What we see here is a reversal. And one thing I want you to note is that program A and program C are the exact same and B and D are the exact same. The only way in which they differ is how things are framed. So instead of focusing on lives saved up here, we're focusing on number of deaths down here. Whenever we kind of switch the scenario a bit, even though it's the exact same in terms of numbers and probabilities, people were actually more likely to choose program D as a result. And so whenever you frame things in terms of losses, people tend to go the riskier route and choose program D. Whenever you frame things in terms of gains, people tend to choose the more conservative route. So A is more conservative than B, C is more conservative than D. So again, framing. Okay. So finally, we're going to talk about creativity. These are our last 2 slides for this video. I know this was a longer video. Creativity, this is the ability to produce novel and valuable ideas. Here we have Mozart, Maya Angelou, and we have Van Gogh. Right? They're all considered to be creative. When it comes to creativity, it can be convergent or divergent. And so convergent means that there is a singular solution. Divergent means that there are multiple solutions to a problem, okay? But nevertheless, creativity involves, again, novelty. It involves thinking in sometimes unusual ways. And it must have some sort of utility. Last slide. So this is kind of an interesting idea in terms of if you want to be more creative. There's an interesting idea here that creative people are creative because they produce many ideas or products. And so consider the case of Thomas Edison. He had over 1,000 patents filed. He is considered one of the best inventors of all time. Creative people tend to be very prolific in their work. Think about authors, Stephen King. They tend to do a lot. It's not always the case to where everything they do is heralded or respected. But again, kind of power in numbers, if you will, right? So the more that you produce, the better, according to this Darwinian view of creativity. That's all I have for you in this video. The next video, we're going to discuss language. And then finally, we'll end by talking about intelligence for this chapter.